Hello. So we will continue with our case studies on the indoor air quality in the Indian context. So in a case study on VOCs in the indoor environments in Mumbai, several sampling locations were analyzed. One was the renovated hall of a central library. Another was a office room with smoking activity. Then kitchen with kerosene stove for cooking. Lab, rooms, a chemical storage room, painting areas. Simultaneously, outdoor samples were also collected or analyzed together with the indoor samples. The analysis was using gas chromatograph flame ionization detector. Sampling was done in the morning for lower areas and during cooking for kitchen. And several organic compounds were analyzed such as hexane, benzene, heptane, toluene, ethyl benzene, xylene and NDK. It was found that the concentrations of N-hexane were high in the lab, possibly because people might be using them, and the indoor to outdoor ratio of hexane and benzene were high. If we look here, these are the indoor values. So hexane and benzene detected indoors, toluene detected, but a lot of measurements are below detection limit. In outdoors, except toluene, again we are looking at below detection in many samples. And this is our indoor to outdoor ratio. So we see here clearly that the indoor to outdoor ratio is very high in terms for hexane, and also greater than 1 to around 280 for benzene, which means clearly there is an indoor source. Whereas for heptane, toluene and all the others, there is the indoor to outdoor ratio went from less than 1 to sometimes greater than 1 also. So when we had 1 or greater than 1, that means there is some source indoors, but otherwise basically they are less influenced by the indoor activities compared to hexane and benzene, where there was a clear indication of the contribution of indoor sources. In the smoking area, due to good ventilation, higher concentrations were generally not observed, and hexane and benzene here also were found to be somewhat higher indoors than outdoors. So you see indoor to outdoor ratio of 1 to 10, 0.85 to 3. And for ethyl benzene, we are also looking at some indoor to outdoor ratio of 1 to 4, but the detected values were either not detected or were very low. So generally we are looking at close to 1 or slightly higher than 1 indoor to outdoor ratio. So well ventilation means even if there was some indoor source, it did not lead to substantial elevation in the concentrations. In ambient rooms without apparent sources, these were used as controls, and in these cases no significant fluctuations were observed as compared to outdoors. And for all the analyzed VOCs, the indoor to outdoor ratio was generally 1 or less to 1, close to 1 or less to 1, sometimes slightly higher, but generally close or less than 1. Of course, we are looking at a natural setting, so there will be fluctuations also. In the chemical storage areas, there are several, like 4 samples were collected. In all those samples, the hexane indoor to outdoor ratio was always greater than 1. Here it is 4.5, here it is 12.2, here it is 3.6, 2.5. For benzene also, the I2O ratio is 1.4, 21, 5 and 3, suggesting that there is an indoor source. And it is understandable because hexane and benzene might be used in like chemistry lab or in experiments, and therefore there will be some sources in the chemical storage area as well. When we look at heptane, toluene, p-xylene, orthoxylene, N-decane, or p-xylene and O-xylene and N-decane, we have values indoor to outdoor close to 1 in the first sample, which means not either no substantial indoor source or it is sort of being flushed by the outdoor air, one of those. Here we have moderately, just slightly above 1 indoor to outdoor ratio, and here also slightly above 1 indoor to outdoor ratio. So generally one would expect that most of the chemicals are emitted to certain extent in the chemical storage area. So therefore the I2O ratio then is also influenced by how strong the indoor source is and how well the ventilation is. If the indoor source is very strong compared to ventilation, we are going to see high I2O ratios, 12, 20, 5, 4.5. So this is how one can interpret I2O ratios and the relative strength of indoor to outdoor emissions leading to the indoor air quality. When we looked at VOCs in the painting areas, it is understandable that the indoor to outdoor ratios are going to be high in general. So we see here that volatile organic solvents in the paints could be vaporized into room air depending on the organic solvent being used. So probably more will be in oil based paints and the less will be in the water based paints, and of course it depends on the amount of paint used also. Now these are again our organic compounds: hexane, benzene, heptane, toluene, ebenzene, p-xylene, O-xylene, N-decane, and some unidentified. Then S1 is a wall being painted with oil based paints here. S2 is a wooden surface being painted. S3 is a metal surface being painted with aluminium based paint. And S4 and S5 are walls being painted with water based paints. Okay. So now when we look at the I2O ratios, we can see that the walls that are painted with the oil based paints had one higher indoor air concentrations, so 80. In the wooden surface we have 467. When we have metal surface with aluminium based paints, 140. But when we have wall painted with wall based paints, the concentrations are much lower, 21 to 26, which are 4 times or even 20 times lower than the indoor concentrations, where one was using oil based or aluminium based paints or wood was being painted. Likewise, we can see their I2O ratios. For hexane, oil based paint 25, for wood being painted 65, for aluminium based paint 28, but for water based paint 2.8 and 8. So even if there is a emission strength, the strength is much higher when one is using oil based or aluminium based paint or painting the wood. For benzene, however, we see that we have oil based paints emitting 21, but the paints which are applied on wood gave the higher amount of benzene. Aluminium paints lower, but one of the water based paint actually gave substantial higher concentrations of benzenes, higher than even the oil based paint. So here the relation was not that clear, and the I2O ratios were still 3, 1300, 6, 22 and 3. Heptane was substantially present, the concentrations of heptane in the air where oil-based paints were used were substantially higher than anywhere else. Here we see 300, here below detection 21.0, 19.7, 30.5. So they were at least 10 times to even more than 10 times higher in the oil-based paints. Let us see toluene 910, 116, 64, 36, 70.5. So again toluene much higher from oil-based paints. E-benzene 472 below detection, 0.3 below detection, 0.2, 2.1. So again much higher in the oil-based paints. Similarly, p-xylene 279, here 4.1, here 200. So here aluminium based paint and the oil based paint had similar numbers. For outdoors 29.8 and then 173. So this water based paint was also some source of xylene. For O-xylene 502, 5.7, 5900. So here for O-xylene aluminium based paint was the highest source, then 20, 29. So aluminium based paint followed by the oil based paint contributed to more O-xylene in the air. For N-decane we are looking at 1400, 6.0, 50.4, 250 and 220. So N-decane highest concentration in oil based paint, then lower in the water based and then lower in aluminium and the wood painting. In general, when we see I to O ratios, we see that most of them are being emitted indoors, but for hexane and also for our p-xylene, e-benzene, we have quite high emissions N-decane in the oil based paint. So when we look at all the compounds as a whole, we have more emissions from oil based paints compared to, let's say, water based paints or even some other types of paints. And in all the cases, I by O ratios were actually high, except very few exceptions, high in the oil-based paints. In water-based paints, in some instances, we did get less than or close to 1.0 I to O ratios. Now, when we look at VOCs from painting, we have summarized that concentrations of several compounds were high in oil-based. Some other compounds were high in wooden surface that were painted. Same thing we can see in aluminium based paints. For some VOCs, we see quite a marked decrease in the VOCs. In renovation halls, in this kind of setting, in that study, the polishing and varnishing works were done during the renovation. Samples were collected after 1 week and then significantly high concentrations as compared to outdoors for toluene and p-xylene. So this is our toluene median of 21 here, whereas here it is 8.1, for p-xylene 11.2, 4.8. So there is a higher I by O ratio. Not that high for benzene. So these renovation and polishing and varnishing did not release probably that much benzene, or the indoor source of benzene was not that high compared to any outdoor source. They were similar, I guess. So the I by O ratio was close to 1, or maybe the outdoor air was flushing it and the indoor flushing the renovation hall, and the indoor source itself was not that high. So but for toluene and p-xylene, we did observe 2.6 and 2.3 I to O ratios, and the concentrations were also high. So I by O ratio and the concentrations should generally be looked together, and they generally tell us some things about the relative importance. Like if the I by O ratio is 500, that means indoor source is very important. If I by O ratio is 1, 1.0, 0.9, So now we are not so sure about the importance of indoor source, but if it is 50, 100, 200, then we know that the indoor source is there and it's important compared to the flushing. When we looked at VOCs from kerosene stoves, benzene, which is here, and unidentified compounds, actually these are unidentified uh, compound, not sources. So benzene and unidentified compounds from this source were the major pollutant contributors. So 15 here and 32 here. So additional studies on the decay pattern of indoor VOCs could be actually helpful in understanding these changes and also the air quality standards. In all these cases, if we see I by O ratios, for heptane we see the I by O ratio 1.1 to 99.2, for toluene 1.0 to 1.8 and 1.27 being sort of the middle value. So for toluene, maybe indoor source is not that dominating, but for heptane and benzene, and also in this case probably N-decane and these unidentified compounds, indoor source seems to be important. In another case study, VOCs in homes were studied in sort of west part of India, and total VOCs were measured using GCMS. And it was found that generally during the mornings in winters, the total VOCs, TVOCs were higher indoors as well as outdoors. Also during afternoons and evenings, they were higher in winter than in summer. And in winters, the concentrations in indoors were quite higher than concentrations in outdoors in morning as well as evening. In the summers, concentrations were higher in the morning indoors compared to outdoors, and somewhat higher indoors compared to outdoors in the afternoon or evenings. So in both the seasons, in general, concentrations indoors were higher than outdoors. So one possible reason given was that maybe compounds emitted indoors during the night may persist indoors if the home is closed or partially closed overnight, which means preventing of flushing. And during summers, opening of doors and windows resulted in a better mixing of indoor-outdoor concentrations, and therefore we are looking at somewhat lower concentrations. And TVOCs were higher in January than in May, probably also due to lower mixing height. So now we are talking about the outdoors. Factors identified affecting these concentrations were related to cooking, plastics used, consumer products, siloxanes in vehicles. They said the temporal difference in ambient compounds could be due to vehicular traffic, and also some compounds or many compounds detected in the study could be related to proximity to solid waste management site in Ahmedabad, and there's a presence of carcinogens and other toxic pollutants were highlighting the need for understanding their prevalence in the indoor setting. Now there was another study on natural ventilated school buildings in Chennai area. So the classroom had around 43 occupants and one door and 4 fans, and the board was blackboard used with chalk and with daily cleaning frequency. It was found that for PM10, during occupation of the classroom in the winter season, the mean concentration was 265 micrograms per meter cube, but when the classroom was vacant, the mean concentration was 104 micrograms per meter cube. For PM 2.5, when the classroom was occupied, the concentration was 70 micrograms per meter cube. When the classroom was vacant, the concentration was 57 micrograms per meter cube. In PM1, when the classroom was occupied, the concentration was 42 micrograms per meter cube. When the classroom was vacant, the concentration was 44 micrograms per meter cube. Similarly, for CO, when the classroom was occupied in winters, the concentration was 0.1 ppm. When the classroom was vacant, the concentration was 0.08 ppm. If we look across these concentrations between occupied and the vacant situations, we see very little change in CO. Again, very little if we are considering the mean and the ranges, very little to no change in PM. Some decrease in mean concentration in PM 2.5, but a large decrease in the PM 10 concentrations. So this suggests, and we know that classroom, when it is occupied or it's being the process of being occupied, people are coming in the classroom, so they are walking in the classroom, and there is resuspension of dust. And maybe the chalk is also, when the teacher is writing on the board with the chalk, there is an emission of the chalk itself. And these emissions are likely more in these emissions from either chalk or resuspension are likely to be more in the range of PM10, because this is where we see increase in the concentration when the classroom is occupied. So mostly PM10 range, somewhat in PM10 range, but not that much in the PM1 range, because there is absolutely virtually no change. So the activities in the occupied classroom were leading to somehow the resuspension or emission of particles in the PM10 range and somewhat in the PM2.5 range. We know, so and then again we see CO is almost virtually not changed, and which makes sense, because if the people are coming and resuspending the dust or using chalk, we are not likely to see a very high increase in CO. So classroom occupation influenced PM concentrations, but mostly in the PM10 range and somewhat in the PM2.5 range, but not in the PM1 range and not for the carbon monoxide concentrations. Then in another city, in Lucknow City Homes, a study was done for almost 1 year, covering 3 major seasons, summer, rainy and winter, and 15 homes were selected, 5 homes in each environment, in densely populated colonies, roadside colonies and well-planned colonies. In general, if we look at the CO concentrations in ppm, in the summer they were 0.6 plus minus 0.4, in winter 1.2 plus minus 0.1, in rainy 0.9 plus minus 0.2. So in general, it looked to be that in the winter season the concentrations of CO were higher compared to summers or even the rainy season. In terms of CO2, the summer concentrations in ppm were 512 plus minus 21, in winters 558 plus minus 20, in rainy 502 plus minus 8. So concentrations in winters were somewhat higher than the concentrations in summer and rainy season. In terms of PM10 in micrograms per meter cube, concentration in summer was 212 plus minus 34 micrograms per meter cube, in winter season 282 plus minus 40, in rainy 189 plus minus 80. So here again, in winters the concentrations were somewhat higher than summers or rainy. In terms of PM 2.5, the concentration in winter season 162 plus minus 21, which is again somewhat higher than concentration in summer of 112 plus minus 9, or the rainy season 82 plus 19. When the health issues were sort of summarized, substantial portion of the inhabitants reported health problems such as eye irritation, dry throat, headaches, sneezing and skin irritation, shortness of breath, cough, dizziness, nausea and cataract even. So in general, of course, it was found that the indoor air pollution can influence health, and then this information can be or could be tried to be quantified. The concentrations indoors were generally often found higher in winters than in summers in several of the case studies. Various VOCs were found to be emitted from like paints, and then they were also found in chemical storage areas and labs. So we can perhaps have more studies on the IAQ assessment and the associated preventive measures.